Hi kids, today we're going to continue about redox, and now we're going to talk about oxygen. Now what happens is these are metals, they're all metals: potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, copper, silver. Okay, so all these metals are able to react with oxygen. Now obviously they react with oxygen at different rates. Now if you have ever seen magnesium in your school, it usually comes as a magnesium ribbon. Okay, so your teacher might cut a small piece and light it up. Okay, now you will realize that when you light up a magnesium ribbon, it burns really brightly. Alright, now if you were to burn zinc or iron or tin, it will not glow as brightly as magnesium. And if you were to burn calcium, it will glow brighter than magnesium. This is because the higher it is in the metal reactivity series, the more reactive it is towards oxygen. So let's look at this. When magnesium reacts with oxygen, it becomes magnesium oxide. So we say that magnesium is oxidized because magnesium gains oxygen. Okay? However, we also say that oxygen is reduced. Oxygen is reduced because it causes magnesium to be oxidized. So, all of these metals can react with oxygen. The higher they are, the more reactive they are, the brighter they burn with oxygen. However, there are certain non-metals that also react with oxygen. Now, for example, carbon. Carbon is a non-metal, but it also reacts with oxygen. And hydrogen is a non-metal, but it also reacts with oxygen. Now, let's say I had a crucible, and my crucible was filled with copper oxide and magnesium. Okay, I heated up this crucible. Who is more reactive, copper or magnesium? So if you look at this list, obviously magnesium is up here, copper is down here. So magnesium loves oxygen more than copper. So when you heat it up, will magnesium try and get the oxygen? Of course. So magnesium will react with copper oxide to produce magnesium oxide and copper. Now if you look at this equation, it's very easy. Magnesium is oxidized to magnesium oxide, and copper oxide is reduced to copper. Okay, so this is a redox reaction. Now, if I find metals in the soil, what happens is the metals don't exist as pure metals. Most of the metals exist as ores. For example, iron will exist as hematite, which is mostly iron trioxide. Zinc will exist as zinc blende, which is mostly zinc sulfide. And aluminium will exist as aluminium oxide or bauxite. So what happens is we need to extract these metals from their original ore into their elements. Now, for example, if I had iron oxide and I heated up with magnesium, would I get magnesium oxide and iron? Yes, of course I would. But that's a really dumb way to do it in the industry, because it would take a lot of money to get magnesium. So what we do instead is we use carbon. This is because carbon is more reactive than iron. So it would be easy for carbon to reduce the iron oxide to iron. Now, for things like zinc, it doesn't exist as zinc oxide. It exists as zinc sulfide. Would we be able to take away the sulfur? Yes, but first what we need to do is we need to change the zinc sulfide to zinc oxide. And after that, we use carbon to remove the oxygen. Now, how about aluminium oxide? Could we take aluminium oxide and heat it up with carbon? Yeah, sure, we can heat it up, but nothing will happen. This is because aluminium is more reactive than carbon, so no reaction will occur here. Alright, so it's very important for you to know that the reactivity series has also something to do with redox, and the more reactive metal will react more brighter flame with oxygen, and a more reactive metal can reduce a less reactive metal oxide. Okay, so a more reactive metal like magnesium can take copper oxide and change it to its element copper. And in the industry, although the more reactive metals can remove the oxygen, we don't use them. Instead, we use carbon because it's so much cheaper. So we're going to be talking about how these ores are reduced back into their elements using carbon in our next videos. See you!